Okay, my outstanding friends, this is going to be fun. This is Myron Cook. He's a geologist, does a whole lot of things on anomalies, which is exactly what I do. Now, he's looking at this anomaly that's somewhere in the desert, and he originally I thought he was going to say it was trees, and he's saying no, it's not at trees, and I'll show you what he does say. But what I want you to look at first is this gigantic hair, and this concretion that's surrounding it. What is this? Why is this underneath that? And then why does it go into this very powdery looking stuff? And why are they broken in these chunks and blocks? Now, I'm going to show you what I have here to present my evidence that it is a hair, and then I'm going to show you every detail why I can make that claim, and I'm going to show you what he claims, and they are very, very different. Okay, my outstanding friends, this is going to be fun. Now, what are you looking at here? Well, that's a hair follicle. All right. Did you know there was a muscle attached to your hairs? That's what makes them stand up on end. When you get shocked and your hair goes up on end, that's this erector pili muscle. Erect makes it go erect. Did you know you have a sebaceous glands? Those are oily little buggers that shoot oil so that your stalk can go up through there. And I don't know if they know this or not, but this thing wraps around and comes up flat and then merges into itself. I'll show you that in a second. This is where your blood supply comes in on the bottom. What I have here in the microscope is a hair follicle from a giant creature. All right, that is a very, very large hair follicle. Now I'm going to be showing it in the microscope up above. Microscope is here, and we can take a bunch of different shots of it, but I'm going to take it from the top first, and then we're going to see the actual sebaceous gland, and we are going to see the erector muscle attachment spot, and we're going to see the blood supplies at the bottom, and we're going to see something that may be new because it's where it comes out of this sebaceous, right above the sebaceous gland. It appears to be flat on one side, as you'll see in 1 second. All right, so let's take a look at what it looks like in the microscope. All right, let's just do it this way. This is that. All right, this is the pili erector muscle attachment right there. Bang. This is the sebaceous glands. I mean, there's no difference whatsoever. That's where the pili muscle attaches. The sebaceous gland is here. Now, at the bottom is where the vein and artery attach. Now, the hair actually goes down and wraps around and comes up. You see it coming down and wrapping around and coming up, and it's actually got a flat spot at the top where the two merge together and turn into a hair. So I think the sebaceous gland is actually lower than they're picturing it here, because on mine the pili muscle is right there. This basically is where the cuticle ends. So the sebaceous gland, I believe, is down here further. And this is basically this bulb right here. All right, I'm just going to let him make his claims here of how that forms, and then I'll show you what I think.
Sandstone. So to have a cast that's filled with sandstone, this would have to happen. You'd have a log in here that rotted away and left a big hole, and then sand came in and filled that hole. And this is really difficult to do because, first of all, it had to be covered to create this shape, this void, right? Covered and then rotted away. So how do you get sand in there? But let's just say there's some little hole or something in there, and that later sand got into that hole left from the rotting log. Well, that's really tough to do, isn't it? Especially with this key observation that there's cross stratification within here. So
not only that, why would there be, they're perfect blocks. They're just exactly perfect. So, you know, and I think he makes that observation that it can't be right.
but we noticed in outcrop that there's these cross stratification represented by these squiggly lines. And cross stratification only occurs when you have relatively high water velocities.
Well, that's not true because I showed you that is the outside layer of, well, maybe I didn't show you yet, but it is the outside layer of hair that has that exact same pattern.
That deposit these move these sand grains along and make bed forms and cross stratification. So now it's, hey, come on. We can't put high velocity water inside a void. It's like a bubble buried in the ground like that. It just doesn't happen. There are some really cool casts, though, of petrified limbs and trees that I've seen, and I'll show you one here in a minute. So it can happen with a slightly different process. So, wow, okay, so we've made that step. We go, okay, it's not the petrified tree. It can't be. So now, what can it be, and what happened, and what is it? Let me show you another sketch. So now the sketch here to help us understand what I think is the best hypothesis as to what is going on or what happened 50 million years ago. But I have two sketches here, okay? One is a river system from a bird eye view, okay? This is the river channel here, okay? And that's a view from above. And
all right, he's really, really stretching. Myron, let me show you what did happen, my friend. If you want to come back here and watch Myron's video, it is called Unravel a Mysterious Outcrop of Rock with a Geologist. And that is Myron Cook's channel. Now, let me show you what actually that is. Well, what Myron is looking at is what's called the dermic coat, which is this. And it does look like bark, like of a tree trunk. And he's seeing that and saying, oh, this is, he came up with some other conclusion that really makes no sense at all, to be perfectly honest with you, Myron, but that is what you're looking at, my friend, is the dermic coat. Okay, my friends, this is another one of these shockers. This is hair under a, a really very powerful microscope, and there's about 1 million layers of skin. I mean, it's unbelievable the number of layers of skin. Then you have the hairs come out, and they're actually in little flat blocks. These are scales around them to protect the ring around, which is a straight ring. These are like little barrels, one on top of each other. Now, I have one in my microscope right here from a mud fossil, and that's the hair coming out right there. And these are all the skin layers around this one. Of course, it's broken off here. Now, I'm going to show you in the anatomical exactly what that looks like. It's amazing. It's got every little bit of architecture. Okay, get ready, here it comes. Okay, a little anatomy lesson. What does a hair follicle look like in your body? Well, there's, you ever have an ingrown hair, you pull it out, it's got that little bulb on the bottom, it turns black. Well, in addition to that, what you probably never saw was there was a muscle attachment. It's called the erector pill muscle. It goes just like this down to, and that's what makes your hair stand up on end. That's what, and you get to, and your hair stands up on end. That's what that muscle does. Now, what else do you have to have? You have to have a sebaceous oil gland, which is these little blobby things that are attached to the side of the hair follicle to give it a little lubrication so that it can come out nice and smooth. Now, mine is broken off right here. But you'll see this is really a wraparound at the bottom. And sometimes they ingrow and then they don't wrap around. I'll show you what it is. I'll show you the actual tooth. And you see the black and the red, the blue and the red here? That is the nutrition for it. It's a blood supply. So I am going to show you this right now in my sample, which is huge. Okay, there is the erector pill muscle, and here it is on mine, attached to the side so it can pull the hair up and down like that. There's the actual center attachment to it. Now, what do you see here? Can you see that sebaceous gland? Just barely. There's the sebaceous gland. This is on the other side, and there is the sebaceous gland here as well. You can see it's almost, well, it's the same thing. That sebaceous gland is right there. All right? You see it? Now, what happens with the hair is it actually grows down, then wraps around and comes up. A little bit different, and that's why sometimes it goes right through the bottom. Now, this is the vein and artery. Of course, they're no longer have any blood in them. This is transition. This is, nucleophilic substitution made it all almost the same material, but it's still, everywhere there was membranes, they separate things. I was going to call this fascia-facilitated fossilization because everything I had membranes on it that separated everything from everything else. But they would turn into the same material, and I would say, how the hell did that happen? And it's because the membranes all have something called aluminum silicates, which is feldspar. And it is the membrane separates you in life just like it does in death. Pretty amazing stuff. You know, I think I said cuticle when I was talking about the hair follicle. Now, right here is the hair follicle, and they're showing the sebaceous gland above the hair follicle. I don't think that's true. This, I believe, is the hair follicle right here. And the sebaceous gland on mine is right here, and it's attached right on the other side of the pili muscle, right here, so it's right over here. So not up here, it's down here. That's on mine now. I don't know, maybe different on that. But I believe this is, well, it's the hair of some giant creature. That's a giant hair. I don't care how you look at it. So, but they all show it the same way. So somebody originally drew it that way, and everybody draws it that way. Because you're never going to see this, really. People don't really do a lot of that deep anatomy, they've just accepted these things and they go for it. Nobody, who's going to look at that and dispute it and start trouble about it except me. That's the sebaceous gland. I'm sorry, that picture is wrong. Alright, this explains a lot in one picture. You see all these little strips and so forth, that's clay. You see all the little balls, the little black balls in here? Those are the interstitium balls. This is a hair. Now, it's coming up through the clay of the skin, and then it will pop out through the top. They form these little barrel shapes. Now, and I call them abrupt transitions, and I believe that is basically an accepted name for them. And there is a ton of abrupt transitions in your body where things meet and they just transition. But they almost like glued together, and that's what you have here. Now, down below will be the follicle. All right? This is called the cuticle on the outside. It's also called the dermic coat, which coats the hair as it comes up through, but this is down inside below your skin level, and it stops right there. That's where the follicle stops. But this does have the erector pill muscle attached, and it also has a sebaceous gland. That right there is exactly what the sebaceous gland looks like. We're going to look at it in a microscope, and then the hair comes up through the top, but way down below. And it seems to have a flat spot. Well, I know it has a flat spot on this one. And I can see it comes, this is the bottom. It wraps down around and then comes up. You see it? You see that? It's wrapping around the ball and then coming up. and then it has a flat spot at the top. It's kind of interesting. And the blood supplies are down at the bottom, but that would be way down inside. That's your follicle. And then the hair comes out through your skin and then up through above. Now you see that? These are sweat glands. Those are the sweat glands that are in your body. And this guy's digging them out. They're thinking they're squirrel holes, and they had all kinds of things for them. Now, there are places they don't have sweat glands, and they are not human. They're different. Once again, I see the same sort of stuff. They show them as all squirrely looking, but they're nice and spiral, the sweat glands. That's what this is, a sweat gland. The ones that they dig up out of the ground, they're pretty uniform, and they spin around in a circle just like that. Now this goes back long ago. I don't know when it was taken, but they're saying this is a corkscrew with its root. Now I don't know if this was the root with that or this was the hair down towards the follicle. I don't know. When they come up through the top, this is what they look like. And this interior will erode out. It's a little weaker than the outside, which is the dermic coat, which sort of wraps around, holds everything. They erode in the center, but these aren't columns for a coliseum or anything. These are hairs. Things are much different than we thought. Here's one coming up out of the ground. Now, here's what I believe on this one. Right down in here is where the hair follicle was. And probably the pill erector muscle went up this way, because that looks kind of red looking. And this, I believe, is where the blood supplies at the bottom came in, and it's sort of fractured off. But basically, that's where I would say that red, muscly looking stuff is going out this way. And it's a, same thing, it's a hair. Now, and then again, this looks to me like the blood supplies are coming in at the bottom right there. So this would basically be like this. And this is just sort of eroded away, or they broke it away, but that's right there. To me, that's what I'm seeing. Now check this out. This is what happens when your hair comes right out of your skin here. That skin is kaolin clay, and there's about 1 million layers. I mean, it's just unbelievable, the amount of layers. And that's what I have shown you, or will show you in some of these pictures. All of that layering. I think I showed one right in the beginning where it had all of this stuff on the sides, and let's go find that one again. There it is right there. That's the interstitium, and this is the skin. In the skin, you have all these little tiny balls that hold the skin so it can stretch and move and do this way and that way, and they will come back to wherever these balls are anchored at. And Myron calls these concretions. And he's got all kinds of ways of coming up with how they end up concreting, but that is just not the case. They are hair. This is a hair. This is skin. These are the anchor balls that allow it to contort and so forth, but basically come back to where it started. Otherwise, you stretch it and that'd be it. It'll never come back again. So, and I can show you the interstitium. They just sort of realized this existed, to be perfectly honest with you. In 2018, there's an article, and you can look into it. It says, meet your new organ, the interstitium. And it shows all these balls in there in a flexible fabric. Whenever they checked them in a microscope, they would see them flat as a pancake. Here you go, read it up. 2018, meet your new organ. And it starts off by saying, how could they find a new body part? Well, I found these back in 2012, 2010, somewhere around there. And I've been working with this interstitium and fascia and all that stuff ever since. Because it's all over the earth, everywhere. And you can't miss it once you understand biology. It just can't be missed. It can only be avoided now. All right, Myron's going to be showing hair after hair after hair, and it's eroded in between them like this, and just showing the hair and all the little bits. And I believe he's right at the end of the root. You see that? Can you imagine how many layers of skin there is? That's a sweat pore on you or me or anybody. A tiny sweat pore. This is all the little layers of kaolin clay, which is the really soft stuff. And you can see that around Myron's hairs. Now this is not a human. There are no sweat glands here. That means it's not a human. And there are animals that don't have any sweat glands. Now, the red and the black, well, this color and that color is blood. That's the oxygenated, deoxygenated. And that's why you see them in the roots of the hairs, they're going to show up. Now, that's Crowley Lake. And it's not a human. And here it is, some more of it. You see it? No sweat glands. And here it comes up through the top. But it's this soft white clayish stuff that just erodes away. That's why all these are showing up, because that other stuff is just extremely erodible, as you're going to see where Myron is. What else do we have up here? Don't forget, this is what he's going to be talking about here, which is the dermic coat. And it's also called the cuticle. The hair cuticle. There's other stuff, your finger cuticles and things like that, but this is the hair cuticle, or if you want to call it precisely, it's the dermic coat. And he's showing it as like water eroded down this way, causing these ripples in there, and it's not that case. It's a hair. So we're going to be jumping back and forth between my shots and what Myron is going to show. And I think my stuff is pretty persuasive. Now, I don't want to demean anybody, and I'm not trying to demean anybody. Myron, I admire him for going out and trying to find out what he's seeing, but he's not seeing correctly. Well, maybe he is. Maybe I'm wrong. This is what discussion's all about, not like this. Imagine being an expert on rocks, some expert on rocks, watching this guy, me, piss on the guy's craft. Look how how can anyone continue watching after he showed us a regular ass rock and said it's a dragon scale? I showed this and I said this is some kind of a scale from a dragonish creature. That's exact pyramid dragon. And I showed the one in the desert. This is the tab right here. That's the little latch. You see that little oblong looking shape there? That's the latch. And it's on human beings too, wherever something locks in place. So if that's not a dragon scale, that's fine. All the other stuff I'm showing is real too. So he's just trolling and being nasty. I'm trying to be nice and get people to pay attention. They won't pay attention. People like this are just pissing on my craft. Okay, here's what we're going to see. This right here is in the microscope. The microscope is way up here. It's not really designed to do this, but I made a change to it and it works fine. Now, what we are seeing, the top of this right here, is exactly right here. The erector pill muscle is right there, and the sebaceous gland is right here. Now, it shows it way up here. I say it's really actually right there. And on mine, there's no question. I showed it to you, and I will again. It's right there. And you're going to see it up in the microscope in a second. Now, first of all, we're going to be looking at the top and the whole thing in its totality. And I'll probably put a little water on here in a second. Now, I have to turn the lights off so that you can actually see it. In the screen above here. Now, that is the hair follicle coming straight up, and all it is up to that white spot that I showed you. Above this, probably 2 or 3 inches of skin or more would be above that in this size of a creature. Maybe a foot. I have no idea. It would be quite a bit. All right, once again, Myron is going to be up in, this is all eroded away. He's looking at the very end of this, and right up here it's eroded away, just where it starts. The erector pill muscle I'm going to show you up in the microscope up above, and I'm going to show you the sebaceous gland, but it is over here, it is not way up there. Alright, so here we go up to the top. That's coming straight up the top. Now, I'm going to bend over here to the erector pill muscle attachment. That is where this attaches and runs up to the flesh. And I showed you in, I guess it was Myron's. No. It was a picture I had in my, I remember. It was a picture I had from somebody else. It wasn't from Myron. But it showed, I believe, what was an attachment right up from the erector muscle. Now, so that's the erector muscle. Now let's go right to the other side. So here we go right over across the top and down to this side, and this is the sebaceous gland. I mean, that's just no question about it right there. That's what the sebaceous gland looks like. See it? And that's where it actually probably, I don't know, leaked its stuff in or whatever, but that's the sebaceous gland. Now down the bottom is where the artery and the vein would have come in, up here. Let me see if I can get a little bit clearer shot of that. That's about the best I'm going to do. This microscope really does, well, I'm about a foot away. Let me come down a little bit further. It's a good microscope, but it just doesn't have the real power. But I guess you don't get everything. Now this, I believe, was where the vein and artery went in the bottom there. You see, you got one here and one there. And then this is actually the hair right here wrapping around. You're not going to be able to see that. Wrapping around. You know what, let me back this off a little bit. That should be enough. Alright, here we go. Now, let's start back at the bottom again. Underneath there is the vein and the artery, way back there. All right, now this is the hair literally coming down and then wrapping back up around itself. You see this? Now this is going up the root this way now. So it's coming, it went down, it wrapped around, and now it's coming up. And now I'm coming around to the top. So it's coming up inside now, up this way, and then it pokes its way up out the top, right up here. Now, let me just secure this. Now, what are we seeing here? Hold on. This is where the hair is coming up. This is what they call, that's the stuff that's on the outside. It's called the dermic coat. That's the dermic coat. And that's the stuff that wraps around the hair. The inside comes out. That's what we were seeing laying around in some of the pictures. So anyway, this is a flat spot. Very interesting. And again, this is the top coming up. Now I'm going to put a little water on it and we'll come back in a second because water always makes things look better. Alright, so I just put a little bit of moisture on there so that you can see the bulb, the, you know, put a little water down here where you'll be able to see quite easily that that is the spot where the mussel attached. It's actually easier to see it this way. Hold on. All right, this is actually much easier to see. You can see the sebaceous gland right here. You can see the pill erector muscle attachment right here. They are both on the follicle ball, the bulb, which is that white part there. It doesn't show it that way in the anatomical. Now, whether this is some special creature, I don't think so. I think this is a human being or some, well, I have no idea. But the stuff I found around here had a human DNA in it, so I could find out what this was. This will have DNA in it. You could drill in there, and there's going to be blood inside here. But you can't just scrape it off the top. And that's why I go inside of them. But these are the blood supplies right there. You could break, just drill right in there. You get past it, and then you're into where the blood would be. But there's virtually no question what this is. Whether it's human or not, I don't know. I have no idea. But it is right to there. And this is not where it's shown. It's here, on the bulb itself. Okay, everybody's seen this dozens and dozens of times. I have the DNA lab reports from 7 years ago, almost 8 now. 3 of them I had tested. I had a lung and 2 giants tested, and they were excellent quality DNA. And it was very, very well done. It was expensive tests, excellent quality DNA sequences. And these were what they found: mitochondrial, cytochrome B, and D loop region, which means they were human. All right, they were human, and he said absolutely no question whatsoever. What I submitted to them was 100%, no question whatsoever, it was human DNA. And so if I submitted a false sample, well then that's me. I didn't. I was very careful the way I collected it, and they were dense and excellent quality. There was 3 of them. Now let me show you this one. This was a really good one. The long one, they were all good. They were all good. Very, very simple, easy to see, just like Caesar here, my goose. This is feathers. You don't have to be a brain surgeon to understand what you're looking at there. It's a goose. Now, the one side is almost always flat on these things because they died in a great flood. And that's why they're preserved this way, because it was a hot water flood. We were almost impacted by Venus. We need to take a look at our ancient history because of the material science, not just because, whoa, this must have happened, this must have happened. No, how did this happen? Explain that to me. Explain that to me, because they cannot. I can. It's nucleophilic substitution. It happens in the hot water floods. Long duration, hot water, salty or acidic. It's pH, it's temperature, it's pressure. I understand the whole thing now. I've done it. I've created them. Not a big thing. Very, very simple. And Velikovsky recorded all of this. So there is my DNA evidence. Let me show you what I did get DNA tested. So what did I have DNA tested? Well, this is the biggest thing I had DNA tested. And I had to, obviously I can't send that off. I had to drill into it and get a sample. Now, you cannot get a sample from the outside of these big body parts. And what body part is it? It's a fingertip. You see this? Or it could be a toe. Somebody said, oh, that's a toe. I don't know. It looks like a fingertip to me. This is the fingernail. I'm going to go with fingernail. All right, I broke this off over here. I just slammed it, and it just popped right off. It's the skin. Literally, the skin popped right off. And I'll show you what grip skin looks like, and it just popped right off. This little round pad, you see this here? It's risen up all the way around there. That's the bumper pad you have between bones in your fingers so they don't scrub each other. This is the vein and artery. Again, fingertip, fingernail. I mean, this thing's huge, 3 feet long. And this has actual fingerprints on it, the piece I took off. I drilled down inside into an artery to get the blood out of there. Now, let me show you the fingerprints. Now that is literally fingerprints, and that came off, the fingernail is up in this area, and that popped right off, and it's about this thick, the skin. And it's just like this. It just came off just like it peeled off. These are the sweat pores, and that's the fingerprint ridge. My finger is about the same width as one of these ridges. And like I say, it's 3 feet long. So I've calculated out, it's got to be 160, 180 feet tall if it was anatomically exact. And they appear to be anatomically exact. Now that's the big giant one. So that's the fingertip. And this is the grip skin from that friction skin, grip skin. Now remember this peeled off part. This is completely different than what's underneath. What's underneath is a red fleshy stuff. This is tough as hell. Keratinized, virtually no blood in it. So where else can we find it? Well, maybe on this gigantic hand. It's another huge hand. It's 4 feet wide. This is also in my yard. All this stuff came right out of my backyard. I don't have to go anywhere. This is the bumper pad that runs around a left hand. If you splay your left hand back like this, right there, right down the center is this cleave. You pinch your hand together, you're going to see it. This side runs off to your little finger, and that little, like, bumper pad is right there. This silver skin is down over this way. And it's the same silver skin as this. And where did we see that before? That's grip skin. That's the tough keratinized skin. The thumb goes off this way. This is a tendon. You lay yourself back. You can see the same exact, if you're a human being, this is where your hand is made. That's it right there. Now, so there's another, and I have all kinds of stuff from this. I have knuckles, and I have fingertips, and I actually have other body parts from this one here. So there we have the big fingertip, 3 foot long one. This is only 4 feet wide. Little puppy. Little infant. All right, I'm sorry. Here it is. This one here has almost, well, it just has a bunch of its pleura eroded away. Now we're down into this area right here. But here, we're in this area. So some of it's here and some of it isn't. All right, but see how it's flat like a pancake on the back? They all, well, not all of them, but boy, almost all of them are just as flat as can be. And they eroded out from flesh, from the bodies of flesh. The flesh just erodes. It turns into sediment and mud and clay. Then bones didn't do so well either. Bones, some of them turned like this, and they did preserve. But not all of them. The bones were, the calcium wasn't like flesh. Flesh preserved very well. It was like parboiled, and then it just was disassociated from the body. Now, so there's another lung. I didn't get this one DNA tested. I didn't get that DNA tested either, but I did get this one DNA tested. And this is this one here. And it was just gushing blood out of here. And this is the same thing here. See how it's flat like a pancake on the back? Absolutely flat. The same thing with Caesar. There's his feathers. He was flat too. And everybody's saying the same thing. They realize, everybody's saying, yeah, they are flat. There's a flat spot on all of them almost. It was a flood. They laid there and took on a form of flatness wherever they laid. And then as the waters receded and the fresh waters came, it washed all the bad stuff out and left them to harden up and turn into what we see today as stones. You see that? There's another lung. They preserve so well. I don't know what creature these come from, but see that? That fills in with quartz where the main cavity was, just like this one has a main cavity, see it? This one just emptied out. You can still see a lot of red blood left inside of here, but primarily it just drained out. Whereas this one filled in with quartz just like this did. So they could go, I mean, they go all different ways. You know, I understand them all now. I understand how it happened. I understand a lot of the chemistry, but primarily the process is nucleophilic substitution, where the molecules that are in there that are not stable will be substituted by other molecules carried in primarily by transition metals. And they will carry in these other stabilizing molecules that will displace, invade, and substitute. It's called nucleophilic substitution. I've done it. It's very, very simple. It's a very simple process, and it's actually going on in your body, in my body right now, continuously, 24 hours a day, because every part of your body has to be literally substituted. It's bringing in new stuff and taking the old stuff out. What's that all about? That's nucleophilic substitution. Here, I'll give you some of this, you give me some of that. That's what it is, invaders and leavers. Okay, Myron is going to be standing on a hair, but only out to about here. It's all eroded. This stuff is really floppy. The hair itself, though, is in pretty good shape. Don't forget, I think the erector muscle's down here. Now, the bulb is right at the very end, and it's only sticking out a very short ways, even though it looks gigantic. All right, let's see what he has to show. But don't forget, I'm going to point to where the ball, I think, is, and then somewhere out around here. He's not even at the edge of the skin. All right, as I said, skin is like clay, and it all erodes away. Now, he's going to be showing an end shot. And again, he is somewhere close to the hair follicle. He may be, well, I'll show it to you. Okay, here's Myron again. And again, I am not out to make anybody, embarrass anybody or anything, but this is a hair. And this is basically the follicle surrounding the hair. And then you're into the skin. That's what this is, and then you're into the skin. Now, this is eroded away, and all you have is the hair sticking up here, but all the rest is eroded away. So, that's what I'm saying is this follicle wall. Basically this right here. You see that? And then the hair. Alright? Now let's listen to what Myron has to say. Because he's saying that everybody does want to know, and he's trying to explain it. But it requires interaction. And he's interacting with people, and I would like to interact. That's all I'm asking for, Myron.
Wyoming, and I want to do this video kind of where I invite you guys to come along with me and unravel a mystery. One of the things that I enjoy about being a geologist is I have people in the communities that I interact with that say, hey, I've seen this really cool thing out in the hills or up in the mountains, and I think it's this or that, or I've heard it's this or that, and they want to know, curious people. And I've decided I want to do some videos where we just unravel geologic mysteries and think like a geologist and kind of walk through how a geologist approaches things that they see out in the field. And that's one of my favorite things to do, is just walk up to random outcrops of rock and figure out what's going on.
You know, this is exactly what I had hoped for, but I need to be able to interact with you, Myron, and respectfully, because this is a whole, I know it's going to change everything for you, my friend, but these things are, not explained exactly in the way you're explaining them. I understand what you're doing. I fully do, but it's just not, it's not what, nobody would, excuse me, nobody would think to expect these things were from creatures. And you've done a fine job at trying to explain it in a geological way, but it's biology. I'm sorry, that's just what it is, buddy. All right, so Myron is going to be doing a series on trying to have us all interact together and figure this out. I want to be part of that, so here he goes.
So here I am at this giant tree. Massive tree. It's just cut right here in front. And the local people think this is a great big tree, and for good reason. Look at it. It's beautiful, isn't it? You can see the edge here, great big. Well, let's get started looking at some details at this particular tree here.
Now, first of all, look at the little balls and so forth that are in here, and this particular layer, which is, I say, this particular layer right here. then you get to where the hair is up under it. Now, and then around the ball is the kaolin clay, which is the white, or in this like yellowish tan looking.
First of all, it's sitting on this beautiful sandstone right here. Beautiful buff colored sandstone. And I've taken a photo with my macro lens to show you kind of what the sandstone looks like. It's a beautiful quartz sandstone primarily, with some lithic fragments or rock fragments within it. So we walk around and we look at this contact, and it is quite a sharp contact, just as you'd expect a big old tree.
This is laying on skin. This is the striations of hairs. It's called the dermic coat. Right? And I showed you this. I've shown you other. Well, let's just look at them again so that we don't get confused. He is looking at this right here. Okay? He's looking at this. And this is the skin, which I've shown you, or I will again, and these are the little black balls. Now, here's the skin. This is how many layers of skin. It's nothing but clay. Your skin is literally nothing but clay. And this is a sweat pore. You can see how, and this is very, very well, obviously pretty well magnified. What else can I show you here? Anyway, that's what it is. And this one right here, I believe, is where the pill erector muscle went from here up to there. And down here is where the blood supplies were. Right down there at the bottom, you see it? And there's the pill erector muscle right there. That red spot is where, same as like this red spot here. And it ripped right out of there. That's what it is, exactly. So all of this stuff is gone, and we're into into that guts right there. I got a lot of stuff. I got a lot of stuff to show, and you know, now DNA testing and all this stuff, I got things that blood just comes right out of them, so that's not an issue anymore. I think I've made my case pretty darn well. So I'd like to see Myron speak to me about this, and we can do this investigation together. He'd be the first true geologist to step forward into this realm. You know, I feel as qualified as any other geologist on the planet. Now, I understand all of this stuff. I understand every single bit of it, the chemistry, the formations, how it all happened. All the ancient texts talk about everything that I've shown you. And it's not accepted by people that can't accept something that wasn't dictated to them. I don't accept the teachers teaching me. I listen. I don't just reject them and say, oh, you're an idiot. Well, most of the time. But that's not my first reaction. My first reaction, well, all right, let's discuss it. What do you got to say? How about this? What do you think about that? And within about 2 minutes, it's, oh, you know, I'm done with you. Get lost. And so I get lost. I get lost. Anyway, that's what we got. So hopefully Myron will work with me, and I will work with him respectfully, absolutely. I admire him for going out and trying to come up with solutions for this, but the solutions he's getting are a little bit they're just not right, based on the fact that he's trying to use the existing geology. It's just like the physicists trying to stay with the standard model. It does not work. The standard model of geology does not work. All right, let's get together. All right, thank you, my friends.